We now look at what we call integration by substitution. This is closely related to chain rule, as we discussed, as you have seen. So, it's a theorem. We are saying that if f is a continuous function and f prime of x, capital letter F prime of x, is equal to f of x. In other words, this is an antiderivative of small letter f of x. Then the integral of small letter f of u of x, composite function, u prime of x dx, is just the antiderivative of u of f x at u plus c, like that. Of course, where u for all functions, u equal to u of x, which have values in the domain of f. And this function u has values in the domain of f, and it also has continuous derivatives. So basically, we're saying that if we're given a function like this, then we conclude that, okay, the integral will be given in this format. So we just need to do some substitutions. Let us see how this formula works, the theorem works. Let us prove it. As a proof, let us pick capital letter F. Say, let us use another function here. G of x is an antiderivative of f, small letter f, g of x, like that. In other words, when we differentiate this function, we get that one. That's what it says. Now we use chain rule. We will note that when we differentiate the left-hand side, this one, we find dx of f, capital letter F of g of x, like this. This is going to give us capital letter F prime of g of x times g prime of x dx. Sorry. Like that. That's what we know. And then multiply throughout by dx. Then you have d of f of g of x. It's equal to f prime g of x, g prime of x dx. Then we can integrate both sides. Then we get the integral of d of f of g of x equal to the integral of f prime of g of x g prime of x dx. Now there is something quite important that you need to recall. You will recall that if you have the integral of dx like that, what is the answer? The answer is x plus c. Right? Why are we writing that? And the important thing is to note that we have the integral sign here and the derivative, the g here. So these just annihilate each other and we're left with x. So let us apply the very same principle here. Suppose if this was x, then it is telling us that, oh, this and that will annihilate each other, and then we will be left with capital letter F, G of x, like that. So let me rewrite this in this manner. Let us say this implies that the integral of capital letter F prime of G of x, G prime of x dx is equal to this one. It's going to give us capital letter F of G of x plus c. Yeah, that's what we're looking for. Now, how can we make use of this? Let us write capital letter F of x small letter f, isn't it? And let us make a substitution. Let's say u equal to g of x. Then there are certain things that are going to happen here. First one is that this left-hand side will be the integral of f, because f prime is just small letter f, will be small letter f, g, it's our u, in brackets, that one is this one, g prime of x dx. How do we replace this? That's the question. Okay, we will answer that. This is equal to f, g is just u plus c in this case. But now we want to do this one. Then you will observe that here, if u equal to g of x, then du dx equal to g prime of x, isn't it? So du equal to g prime of x dx, like that. So if we are saying du equal to g prime of x dx and we have g prime of x dx, it means we can write du then. And this is what we're looking for. Of course, if you want to go on, we may note that this expression is the integral of f of u, let us write u in terms of x, u of x, du, let us come back here. This is our du, and u is g of x. So you can see, we can write this, and then u prime of x dx, which is f of u of x plus c. But so usually that's how we do it, and then we substitute back, and then we write everything in terms of u. And this, as you can see, one may also say is the same thing as f of g of x, g prime of x dx equal to f of g of x plus c, after they substitute everything back to the function we started off with. Now let us pick some examples to show how this works. So to illustrate this, we may follow what has been indicated in our lecture notes, where we gave a summary of the use of this u substitution, that you identify your u, and then after that you differentiate it. After that, then you do the substitution, then you integrate, and then you replace the u with g of x on page 6. Let us take this example. Evaluate. We have the integral, number 1, the integral of say x squared into x cubed plus 2 raised to the exponent, say 7 dx, like that. So in this case, of course, you can see that there's no need for you to first multiply this one out, because it takes a lot of energy to do that. Then what we do is just to identify that which we will call an inside function, and so on and so on. And usually in this case, this is similar than that. So this is like our u, because it's the one that has been, it's a function of another function. It's a function of a function. It's a function of a function. And then this possibility is that it will give us the derivative of what we have picked there. So let u be equal to x cubed plus 2, like that. If you do that, then you find du dx equal to 3x squared, like that. This is what we did here. Let u equal to g of x, then du dx equal to g prime of x, like that. So we can rewrite it this way. Then du equal to 3x squared dx, like that. And then from there, the reason is we want to replace x squared and dx here. So we can see that this is 1 over 3 du equal to x squared dx. So x squared dx, it's appearing there. So this can also be written as the integral now, you can see x squared dx is 1 over 3 du. 1 over 3 du. This is your u. 7 du. There you are. So, this is equal to 1 over 3 u 7 plus 1 over 7 plus 1 plus c, which is 7 plus 1 is 8. 8 times 3 is 24. 1 over 24 u exponent of 8 plus c, but we started off with this. That's what we are interested in, this one. So we have 1 over 24 u is x cubed plus 2 raised to the exponent of 8 plus c. That's how we do it. That's how we do it. That's how we do it. Let us take another one. So you can see how we made our substitution. When we write u, we just have u. We don't have x and u actually together, because we made the substitution that way, the variables. Let us pick another one. The other one, number 2, is the integral of okay, let's take x the exponent of 5 square root of x squared plus 1 dx. Then of course we cannot multiply this x to the power 5 in there. It is not possible, but we note that we may have a function within another function. This one looks like a function within another function. It's a composite function, this one. So we can let our u to be x squared plus 1. Okay, so if u is x squared plus 1 like that, what do we have? We have du dx equal to 2x. And write it like this. So we have 1 over 2 du equal to x dx. But here we've got x to the exponent of 5. So this, observe that it can be written as the integral of x, or for this, square root of x squared plus 1 times x dx. This is what we have there. Okay? Furthermore, this is just x squared all squared, square root of x squared plus 1 x dx. And you can see that this is what we have here. Square root of x squared plus 1, x squared plus 1 is that. Now we are left with x squared. We do not know how it looks like. So, using this, we can see that this one means x squared plus 1 equal to u, right? So x squared equal to u minus 1. Like that. So we are done. We have x dx is half 1 over 2 1 over 2, the integral of x squared is u minus 1 squared. Let's square it like that. This is our u, 1 over 2, because we have the square root. X dx is part of this one, which is du, like that. So this is 1 over 2, the integral of u squared minus 2u plus 1 du, like that, which is 1 over 2, the integral of multiplying everything, about u, 2 plus 1 over 2, it's 2.5 minus 2 u 3 over 2 plus u 1 over 2, all this du, which is equal to the half. Then we integrate. This is u plus 1 there, which is 7 over 2 times, or divided by 7 over 2, which is 2 over 7, minus this 2. Then we have got u, the exponent of 5 over 2, divided by 5 over 2, which is like 2 over 5, plus u, add 1 there, you get 3 over 2, divided by 3 over 2, which is 2 over 3, plus c. And this if we simplify, we get u, the exponent of 7 over 2 over 7, half times that, minus 2u, 5 over 2 divided by 5, plus u, 3 over 2 divided by 3, plus c. We started off with x, so we replace u with our x. So we have x squared plus 1, 7 over 2 over 7, minus 2 over 5, x squared plus 1, the power of 5 over 2, plus 1 over 3, x squared plus 1, power of 3 over 2, plus c. There we are. So if you want, you can write 1 over 7 square root of x squared plus 1. 7 minus 2 over 5 square root of x squared plus 1 exponent of 5 plus 1 over 3 x squared plus 1 square root x squared plus 1 cube plus a constant c. That's how we deal with that one.